Hey, good afternoon, everyone. I'm Amber Bainline, and the HPDF team is here today to tell you about our status and plans for the High Performance Data Facility. We're really excited to be giving this. This is our first open public forum at which we've presented any information about HPDF, and we're looking forward to your feedback, which we're going to ask for in writing, since we probably will not have much time at the end of this to take any questions. So we're also unveiling our website. So this is a number of firsts for us. So we're, again, really excited to have you here and to tell you about this project that is animating all of us, taking up our days and nights. So next slide, please. So the outline of this talk will first be myself telling you about our vision and our background, design overview from two of the project team, the technical team, Graham Hayes and Shane Cannon. Graham is from JLab and Shane from Berkeley. And then the science engagement partnership, and then the spokes will be told, that story will be told by Lavanya Ramakrishnan. I hope I got that close to right this time. Next slide, please. So one of the things we normally, when we give this talk, we have a little bit of an intro to, so I'll just back up just a second. So the project was, the site selection was announced last October with this idea of a joint project team between Jefferson Lab and Berkeley. And I think we're both really excited about the potential that that brings because of the complementarity and the strengths of the two labs. So in both cases, we have decades of experience with scientific missions and user communities. And we also understand the importance of resilient distributed infrastructure that supports the full data lifecycle. And there's also that commitment to the data lifecycle, which is something that we share in common. And then we also have a shared commitment to the Integrated Research Infrastructure Initiative and the ASCR ecosystem. I'll say a little bit more about that in a few minutes. And it's important to have a strong team like this, a team that has these shared values, because HPDF will be a first of its kind SC user facility. And that distributed operations model will be essential for the long-term success and also for the required performance levels. As part of the IRI initiative and the blueprint activity, we heard about the importance of this from the user communities, and HPDF will be one of the ways in which ASCR addresses that as part of the IRI initiative. And then one of the things about HPDF is it is a 413 project that has some, constraints, which we're mindful of in terms of what you can and cannot do within a project structure, but that structure is now fully integrated with JLab and Berkeley and working quite well, if I say so myself. Next slide, please. In terms of the governance of the HPDF project, we have a steering group for HPDF. We answer, of course, to our sponsors in the Office of Science and the field operations officers at Jefferson Lab and Berkeley. And you're hearing from many of the project team members this afternoon. Everyone except the project managers, who are probably waving from the background right now. They're not going to be speaking today. And one of the other things to understand is our linkage to the IRI is through the management council of the IRI. And we did give a version of these slides to them earlier, so to make sure that they are fully aware about what our status and plans are as well. That was a more contained meeting. As I said, this is the first real public unveiling. Next slide, please. So talking a little bit about the integrated research infrastructure, this is this idea of delivering seamless and secure interoperability across all of the national lab facilities. So there's 28 different user facilities. And how is it that we can bring advances in computing, understanding the data lifecycle to all of these entities? And the IRI is the way to do that. And one of the things that was done as part of this IRI architectural blueprint activity was an extensive amount of user interviews. Probably many of you who were on the call were part of those user interviews. And 3 broad science patterns were defined as part of that demand and put requirements on the research infrastructure interoperability. And we have outlined these patterns here: the time sensitive, when you need results back very quickly, data integrative and intensive campaigns and patterns, where you can do a scientific result that is greater than the sum of its parts by bringing together data from different sources, and then long-term campaigns where the processing may need to take place over months or years, or in some cases, perhaps even longer. So you'll see those. Patterns come up through the presentation, so that you can see how it is that the HPDF is interfacing with and meeting the requirements of the IRI. So one of the things that our mission is to enable and accelerate the scientific discovery by delivering the state-of-the-art data management infrastructure capabilities and tools. One of the other things about this is that we are going in concert with the IRI. They're a program, not a project, but they are also starting to make a lot of progress. And I certainly don't want to steal their thunder by talking too much about what they've done. They recently gave a presentation at the ASCAC meeting in Washington, D.C., just at the end of May. And certainly if you're interested in seeing the status of the IRI, I recommend that you go to the ASCAC webpage, and you should be able to see the slides and the recording. If it's not up now, it will be soon. Next slide, please. So what is the HPDF? Well, first off, what is the ASCR ecosystem? So within the ASCR universe, there are 4 existing facilities: OLCF, ALCF, NERSC, and ESNet. And so what's shown in this diagram is this interconnection between those entities, between using ESNet as the data transport. And also you can see the HPDF coming into play as part of that. And one of the elements of the IRI is to take this level of connection, not just at the networking level, but also in this more full-throated way of supporting different user workloads in a seamless access way. This is a very ambitious plan. However, it also really gives, as we go into the future, with the different types of workloads that are coming in now through, say, AI/ML, this gives the ASCR facilities even more of the ability to be a force multiplier for the different sciences, as well as being research projects in and of themselves. So that's how that fits together. Those of you who are following along with these things, there was a charge coming from Dr. Berhe out to the facilities to talk to the forward-looking plans of the different facilities. And the ASCAC subcommittee that looked at that really spoke strongly about the concept of having an ASCR ecosystem, even one that extended beyond the capabilities of the IRI. That, again, is something that you can look at on the ASCAC website if you want to see the closeout that was presented by that committee. So, of course, HPDF, one of the things about it, and again, responding to the requirements from the users, is that having this distributed infrastructure will build in availability and resilience in a way that would be difficult to do without doing it in this distributed way. So this is a really exciting design choice that was made at the site selection, and one that we're looking forward to really leveraging. Now, the next thing to understand about HPDF is it is a hub and spoke model. So the hub is the 2 entities at JLab and Berkeley acting as one hub, but there will also be these spokes that are associated with that. And Lavanya will tell you a lot more about the spokes, how we are envisioning that. But the idea there is that this will be the way in which these data lifecycle services are provided to the scientific users. And since the folks in the Office of Science collaborate worldwide, this will be services that are available worldwide. And one of the things that we'll be doing as part of this 413 project is to pilot activities and partnerships that'll help us refine the design for the hub software and hardware technology, and will also help foster the workforce development that will be needed as we start to realize this data lifecycle vision. Next slide, please. So coming back to this, just in concept, what are the parts then? So there's the hub, there's the spokes, which is that distributed data-centered infrastructure that will enable the access for the science users. But then all of this has to be knit together with these integration and services, where there will have to be some orchestration hardware, software, services for data movement, storage, retrieval, and then science workflow automation. And one of the great things is that we're able to build the mesh data fabric on top of the ESNet 6 capabilities, and then extending that into the future as ESNet continues to upgrade. There's a lot of exciting technical developments in networking now, and we are thrilled to be able to leverage those. Next slide, please. So what are our key goals and what are the capability gaps? So of course, first and foremost, one of the things we have to do is support the IRI vision, right? Making IRI a success is something which is important to all of the ASCR facilities, and investments have already been made in supporting that vision. And that will enable this access of the compute network and the experimental facilities. We also want to specialize in advanced infrastructure for data-intensive science. We want to apply FAIR principles and data science to SC data. If data is the new oil, then it's important to make sure that we treat it as the precious resource and asset that it is. So we want to advance the state of the art, unleashing the potential of data and science to power scientific discovery. We really want to build and enable deep interdisciplinary science partnerships. We want to enable a seamless curation, data curation, analysis, and movement. That's something that's really critical, to our fabric, is thinking about doing this seamlessly as part of moving through the entirety of the data lifecycle. And we want to become a center of innovation for data-focused research, and we want to democratize data access. So those are all of the principles that fold into the way we look at supporting the full data lifecycle. Next slide, please. And so this is the way we think of the data lifecycle, and people will enter it scientifically as in different spots, depending on what it is they're doing. And so we tend to think of this as sort of a circle around, a virtuous circle, really, of gathering data from the user facilities in terms of just raw and derived data, the stuff that comes off of the instruments. Then that data has to be acquired and prepared, and that experimental and observational data and perhaps reprocessed data will get ingested using standard APIs. The data then gets transferred using ESNet as the vehicle for that. Then data gets analyzed, cleaned, processed with scalable scientific and AI/ML workflows. Then the final steps here are to preserve that data when necessary, when important to do so, with long-term curation and archival facilities, and then to publish the data fulfilling FAIR data principles for scientific data, and then pushing data out into some scientific gateways. And then from that, repeating the cycle as new experiments come in or as data gets reused. Next slide, please. So in terms of supporting the IRI science patterns, here we talk through the drivers, again, that I had mentioned earlier, and you can see how those are meant to impact a variety of the IRI patterns. So we see supporting data curation, repositories, and archives as being something that's particularly important when you want to do data integration over multiple data sources, and also for long-term campaigns when things are going on for a long time scale. In terms of the data processing and analysis pipelines, that supports all three of the IRI patterns. Data federation and sharing and collaboration, again, is perhaps most critical for the data integrative and the long-term campaigns, where real-time streaming and analysis and processing is an element that is perhaps unique to the time-sensitive. So these patterns are widely seen, and these are part of what it is that we will be working hard with the users to understand, refining from this idea of the IRI patterns into the particular instantiations, which will help the science communities as part of building out the spokes. Next slide, please. So in terms of the key facets of the data requirements, remember that FAIR is a set of principles, and so we have to actually implement those principles in a particular way. And doing so involves having the scalable management systems, being able to capture the data, being able to stage that data, putting it where it needs to go in order so that it can be processed, archiving the data, and processing the data. And so one of the things about this, where we will play a role, is that the policy surrounding data and providing the collaborative environments around data, these are also critical ways of using data as an asset. Next slide, please. And so then how is it that we see HPDF in the ASCR ecosystem from this perspective? Here we see the ingestion of the simulation data from the computational facilities. We often say observational and experimental data, but the data that comes from the large-scale computational science simulations is also an extraordinarily valuable source of data and very important as we do the data integrative pattern, as most of the science we do in the Office of Science is hypothesis driven. So you want to compare theory to experiment or observation. The data transfer, of course, will be using ESNet. We'll be leveraging the LCFs and NERSC at scale in order to do the compute and processing. We're not, we have a niche in this environment, and it is not to replace OLCF, ALCF, or NERSC, right? They're very distinct roles and responsibilities that each one of these players has in the ecosystem. And then finally, coming around to the other side, we'll be leveraging OSTI because they are already in the place of doing a lot of work with the publications, making the data in the publications available, providing DOIs. And so they are, again, natural partners within the DOE ecosystem for us to work with. Next slide, please. And so with that, I will turn this part of the presentation over to Graham Hayes and Shane Cannon.
Hi, so I'm going to talk to you about the design overview for the HPDF. Since this is a 413 project, we're in the conceptual design phase, so fleshing out a few more details every single day, but just to give you a high-level view of where our thinking goes. Next slide, please. So this slide talks a little bit about the technical design and core capabilities of the HPDF. So what is it we are trying to do? So as Amber said, there are three parts to this distributed infrastructure. There's the hub, the spokes, and then what I like to call the glue that holds everything together. The hub, since everything would rely on hub services being available, has to have a very high uptime. It also has to have experiment-friendly availability. And for this, I mean that we have to be ready to provide our services when the experiments need them, rather than asking the experiments to wait until we're ready for them to take data. We have to have data-driven agility. So as data rates go up and down during the course of an experiment, we can track that and provide services that expand or shrink depending on what the demand is. Obviously, we've got to support new technologies. AI is very hot at the moment. Who knows what will be hot in 10 years' time? And a great part of what we do will be data storage, data management, and providing the interoperability between different data sets. And then finally, long-term data preservation, particularly as the archive of last resort for data that isn't stored anywhere else, but has to be preserved long-term. The spokes provide several things. One is as a kind of user support outpost to reduce the burden on the hub of the large user community and to provide scientific application tailoring that is specific to the community that the hub serves. And Lavanya will talk a little bit about that later. We will provide hardware resources the spokes that mirror or supplement the hub resources, again, to reduce the load on the hub, but also to add responsiveness and lower latency for spoke users. And then finally, we will provide low latency, high bandwidth coupling of all of the HPDF services to edge compute. So you'll be able to see your data catalogs from the beamline rather than having to have long latency data paths. Again, the orchestration, data-centric, the data fabric part has to have the high availability because it underlies everything. And I have to emphasize that this is a mesh data transport. So if you think about a hub and spoke model, you get this idea in your head of the hub in the middle and the spokes on the outside. So one spoke would talk to the other via the hub. That is not going to be the case. Spokes will be able to talk to each other. Users will be able to talk to spokes. The hub will be able to talk between its two components at Berkeley and JLab. We're going to provide secure data paths. Cybersecurity is at the forefront of our minds, but also data integrity and just making life a lot easier for our users. Across all of these things, monitoring is extremely important. We want to be able to be sure that we are doing the right thing on a day-to-day basis, but also provide the information back to the user community that gives them the confidence that they are getting the services that they require. And then finally, the orchestration of the whole thing, the movement of the data around between the different pieces. So next slide, please. So this is looking at the same things from a different viewpoint, which is how are we going to deliver these capabilities? The spoke interface will have all of the user-facing APIs. So not only the command line APIs, but things like the Jupyter notebooks or the web services. It will provide interfaces to local resources that are at the spokes so that they can take part in HPDF. It will provide data caching and data management services. The mesh data fabric, one of the important points about it is it's going to be a service level expectation-based data transport. So you will be able to negotiate an expected quality of service with HPDF, and we will make our best efforts to keep up with that quality of service and provide what you need. It'll provide intelligent data distribution and data caching, so the data is always where it needs to be when you need it. The hub has basically four main categories of technical technology areas. System services provide all the scheduling and the orchestration, the monitoring, the authentication and user management, and all of the user and operator-facing APIs you would expect to see when running code inside the hub. There will be storage systems for the data caching, an archive cold storage system, and then a high-performance hot data storage to go along with the compute systems that are local to the hub. We'll have data services. One of the things I wanted to emphasize about HPDF is we do not intend to be a repository for all of the DOE data. If data is already archived in an acceptable way somewhere else, we will attempt to provide a data catalog and federate those systems together so that scientists can, via HPDF, have access to data when they need it. From the compute side, again, this service level expectation-based heterogeneous computation, where we've set expectations for what HPDF is going to provide, and then live up to those expectations. The systems will be configured to maximize availability and dynamically size according to the demand. Our design methodology for providing these things, which Shane will go into a little bit more depth, is based on a pilot and phase delivery. So we will have a test bed, a pilot system, an early access system to allow fine-tuning of the design before we go into production with a full-scale system. We aim to use proven technologies to ensure reliable, robust platforms, and the hardware will be distributed and replicated both at JLab and BNL to provide reliability and geographic diversity. We're taking a modular heterogeneous approach so we will support a broad range of analysis, the idea being that the user should not have to modify their code massively to be able to use the HPDF ecosystem. So this approach to delivery and modularity will allow us to tailor the composition of HPDF computation and storage systems during the design phase before we settle on what we are finally going to deliver. Next slide, please. So this slide, I want to talk a little bit about some of the unique hardware capabilities that the hub will have. So we need to combine high availability, flexibility. We need to support time-critical workflows. And trying to come up with a one size that fits all of those things is a really difficult task. Again, also we need composable storage to limit the need to modify existing code. So a user should be able to see the storage system act as they expect it to, as if they were working back at home. The local archive will be available along with this federated data catalog, so you can archive your data either locally or elsewhere. Our data processing design is based on what we call the concept of standard units. So rather than one big machine, we have a cluster of clusters, each one of which has hardware elements that follow a well-defined architecture that targets a specific use case. So for example, there'd be standard units aimed at batch jobs, AI/ML, streaming, real-time, and then dynamically reconfigurable hardware. The mix of CPU and GPU flavors will be chosen to run existing optimized code. The hub will also incorporate a range of standard units in a mix that meets the science needs at the start, but can evolve over time by changing the ratios between the CPU and GPU flavors. Again, this is not a one-size-fits-all approach. It's explicitly designed to allow tailoring to the needs of the science and lowering the barriers to HPDF use. I believe the next slide is over to Shane.
All right. Yeah. Thanks, Graham. Okay, so sitting on top of the hardware capabilities that Graham just outlined, we're envisioning a layered architecture that will provide a comprehensive set of services and capabilities to support both the breadth of IRI kind of patterns as well as the full data lifecycle. These are going to provide a common set of APIs, services, and interfaces, and this will help us support portability and also help to distribute these services across and workflows across the hub sites, which will help with resiliency and availability. And this layered architecture will also have a set of low-level data fabric and orchestration services to support, again, to support resiliency, and then layer towards this higher level kind of data lifecycle services. This layered architecture also has the benefit that it allows communities or projects that maybe already have existing kind of stacks, they can kind of enter in at the layer that makes sense for them, while other communities that are maybe more greenfield, they might choose some of the higher level services that we plan to provide. On the right and the left, you see security and monitoring and telemetry. You know, these are cross-cutting pieces that really need to go across all the different layers. So security, again, has to be integrated through these different pieces, and monitoring and telemetry are needed both for operational kind of needs, but also for users to be able to make sure they're making effective use and monitoring how the systems are working for them. Again, all of this is being designed in close partnership with the broader IRI program, especially when we think about APIs and interfaces. All right, next slide. This is meant to kind of give an overview of the breadth of data services and kind of capabilities we're expecting that will be needed to support the IRI patterns and the full data lifecycle. There's a lot of details here, so I'm not going to go into all of them, but what I want to emphasize here is some of these pieces will be specific to certain IRI patterns, and while others are maybe more cross-cutting and support multiple patterns. So for example, just taking one, that upper left corner, you know, time-sensitive patterns will need special tiering and replication kind of capabilities. To support FAIR, which is important for data-intensive and long-term campaigns, we need mechanisms to capture metadata and provenance as early as possible and throughout the life cycle, including derived data products. Streaming data is important. Streaming is important to time-sensitive patterns, but also be used for things like data-intensive patterns. And this is something that we, again, would do in close partnership with ESNet, being sure to leverage the capabilities they have. And so this is not a final list. This is something that we're still iterating on. And, you know, this is something we're going to do in close partnership with through our scientific engagement process. Next slide. One kind of recurring question we get is, are we going to build everything our own, or are we going to leverage existing software? So, our intent is to leverage existing software as much as possible and exploit what's been developed through the community and by DOE projects. This diagram is meant to kind of illustrate the process that we intend to go through there, where we're identifying, potential software products that might be relevant and evaluating those, and then integrating those. So, as we're identifying ones from the DOE community, including things like ECP and IRI, our stakeholders, the open source community, as well as vendors. And we'll consider how these, when we're evaluating, we'll consider how they address the needs of the user communities, as well as considering things like sustainability and usability as well. And even when there's an existing solution out there, I think it's important to recognize there's work to integrate these into some, cohesive framework. And in some cases, we may even identify gaps that, we have to address ourselves. So that's something we're going to be very judicious about, but it's something we need to kind of allow for. So those could guide future improvements. That could be R&D, something we do in partnership with the R&D community, vendor NRE, or even co-design efforts in the future. So again, all of this is being done in close collaboration with the IRI, as well as our science engagement and partnerships, which Lavanya is going to talk about next.
Thank you, Shane. So I'm going to talk next about science engagement and partnership and outline some of our approach and current thinking around spokes. Next slide. So science engagement and partnerships, as you've gathered from Amber, Graham, and Shane, are very critical to HPDF success. As Amber mentioned already, we have a close partnership with the ASCR facilities and IRI. Our goal is to create a continuum ecosystem to meet the needs of the end users. We'll also be engaging heavily with the DOE SC user facilities and projects that have a significant unmet data needs today, both in simulation and experimental data. And our goal here is to build on current knowledge, but also engage with the users to understand their evolving needs to inform our design and shape the end user experience. Additionally, these facilities and projects also bring expertise as well as services and tools that are important to the larger community, and we will figure out ways to partner with them to make this available to the community. We will also work closely with DOE SC program managers to identify current and future needs of the various SC programs. As Amber mentioned, we've already had a few presentations to engage with these communities, and I'll be listing some that are coming up as well. As Shane mentioned, ASCR Research has provided leadership in the data ecosystem for the last couple of decades now, and we'll be leveraging those to both inform and influence what HPDF builds, but also we will be able to inform and influence the future research topics that need to be developed further for future of HPDF and the data ecosystem. There's a rich open source data ecosystem, including in emerging AI and ML, and it's important for us to leverage and contribute to that data open source ecosystem, and that is on our horizon. Needless to say, we will be engaging with vendors to understand the vendor roadmaps towards deploying the world-class data facility in the long term, and also with national and international partners so that we can leverage existing efforts, but also establish leadership in key areas. Next slide. So one of the questions we get asked a lot is, how can the larger community interface with our project? User and community engagement are core to our HPDF strategy and plan, and there are many ways we are doing this through the course of the project. There are many dimensions to the user community that we need to cover. And for example, we do need to consider all the offices and science domains that you see on the left of my slide here. Next, as we consider spokes and community partners, we realize that we need to again engage a broad spectrum of stakeholders, and that might involve getting a 30,000-foot view, which is on the long-term plans and visions from program managers, facility leadership, and maybe computing technical leads. But also we need to engage with the people who are on the ground, who understand the immediate needs and challenges, and engage with the facility end users, PIs, postdocs, students, and the facility scientific staff and community engagement staff. So we have a number of activities we are planning to cover the spectrum of spokes plus community stakeholders that we want to engage in the coming months and years. And I'm going to talk about that in a little bit more detail in the next slide. Next slide. So again, what we're trying to do is balance the breadth with depth. So here are some example activities we are planning on. For example, we expect some kind of quarterly updates and roundtables such as these that we will be ongoing and continuing, which will be in a virtual forum. We'll be engaging with the community both in person through strategic conference outreach, organizing and attending HPDF related BOF workshops at relevant conferences. We will have a coordinated effort to identify needs and priorities to form initial spokes. And that will be starting up with our summer IRI meeting, IRI and HPDF meeting, and continuing over the course of the project. We will use these higher level activities, the 3 upper boxes, to then also sort of determine some next level down activities, which would include one-on-one small group interviews so we can flesh out needs, challenges, plans in more detail, working closely with program managers to identify and evaluate needs, challenges, and visions for specific programs. And also sort of co-design-ish spokes workshop where we can gather requirements and design roadmaps for spoke software stacks and things like that. So we're still pretty early in the project, and amount of any of these activities will vary based on HPDF project needs and available resources. But our goal is to really engage the community at large and get feedback continuously and iteratively through this process. Next slide. So in terms of our user and community engagement, I wanted to highlight sort of 3 sort of main exemplars, which will give you a flavor of what we will do. User research was used in developing the IRI requirements, and we will be using that in our engagement as well. What user research gives us is a process to verify, validate our intuition about what the user needs, and convert it into action and designs, and use that to evaluate prototypes and things like that. User support is something we think about a lot, and data ecosystems are specifically very complex. And thus, user support and data stewards are going to be critical to ensure users can leverage the resources effectively and efficiently. And so this type of support model will allow us to address the computation and data needs early in a project lifecycle and work in partnership with projects and user facilities as we do that. But last but not the least, we believe on a very deep partnership model that will be based on the cooperative stewardship model that's been successfully used in many of SC's user facilities already. What we anticipate is that this model will help us serve the needs of the users better, will help us mature data stewardship across the SC complex, and more importantly, also develop a data-aware workforce that's very critical as we handle the large amounts of data that our community is facing. Next slide. All right, so the next part of my presentation is about spokes, and a key part of our engagement and partnership strategy is grounded around these concepts of spokes. Spokes are something we are working on very closely right now. I'm going to outline our approach to spoke design and models and articulate where we are with our thinking as of today. We would value any feedback and thoughts you have on it, and the link to the form where you can provide questions or feedback is in the chat, but I'll also be bringing it up at the end. So one way of next slide. So I wanted to bring this back to the diagram that Amber showed earlier. So one way of looking at spokes is through programmatic elements. So we could have spokes associated with institutions, programs, or projects that work in this larger ecosystem of both OSCR facilities, but the SC, DOE, SC user facilities and projects. Next slide. But one behind. But it's important and nuanced to know that there are many facets to spoke design, and we need to consider that when we are thinking about spokes. So here's some sort of key facets to the spoke design that we've been thinking about. And we've identified these 8 key facets to date that we believe will be critical as we approach the design of HPDF spokes, right? One is funding models. How is the spoke itself is funded, for what lifespan, and how end users are economically supported through subawards, allocations. All of that can matter in how the users leverage the resources and how it is serves the larger community. The scientific scope is always important as we see more interdisciplinary science, sometimes crossing the traditional science boundaries, are evolving, and we need to be able to serve these diverse communities as we think about this project. Planned permanence, that is the intended spoke lifespan is important. Is this a long living spoke or a spoke that exists during the data generation phase to ingest data into HPDF? The size of the spoke is important. The size of particular spoke is expected to be shaped by the confluence of anticipated user base, data volume, velocity, quantity of resources, both the staff as well as compute. An important another factor for many of us and many communities is what types and extents of technical functionality that the spoke supports for its user community and how it interfaces with the hub. I'll come back to this in a bit more detail next. Additionally, the community structures can matter. How strongly or loosely governed or united the community is around a set of policies or goals for its data products can define the spoke characteristics, and it needs to be considered when we think about spokes. IRI patterns, the type of patterns a spoke is going to support will affect the nature of the spoke and something we need to consider. And last but not the least, the organizational structure will matter. How the organization or institution is designed to support the user community's full data lifecycle. So what we're trying to do here is really use these key facets as guiding principles to look at the matrix of spokes and their characteristics. These key facets will help us identify strategic partners while also prioritizing the community needs. Next slide. All right, so what we've done is sort of take those key facets and develop them into spoke model concepts. Really what we're doing here is trying to come up with some models that will serve the needs of end user communities and be tailored to these specific communities. Why is that important? Because diversity of science today is a driving force when we think about the HPDF design. And it's also important for us to scale this so we can have a wider impact, since there's already a significant unmet need in the data ecosystem. So these spoke model concepts really have the ability to increase the surface area of science impact and also developing the community and workforce. And thus our approach is to partner often and early. So I'm going to walk through this slowly here. You can see the projects and end users may come directly to the hubs and would interface with the hub to leverage resources. And spoke type A might be a case where you have the spoke itself provides edge services close to the experiment or instrument and interfaces with the hub through APIs. So it's more traditionally sort of data gathering from an experiment and working closely with the hub to serve the needs of the end users. Spoke type B is much more where spoke might provide some computation and data services at spoke and also leverages the computational and or data services at the hub. Spoke type C, which is sort of a higher level of potentially partnership where you may be co-designing software services with the hub and also providing hardware or services to the community as a whole. The spoke type D is a slightly different thinking here, where we think there may be communities that want to come together as a forum and co-design additional software services for that community by interfacing with the hub. But they themselves might then have instantiations of spokes that maybe are slightly different and are able to serve the needs of the end users. Spoke type E is really a type of spoke where the users or the spoke are relying on hub resources for largely preserving and publishing data, and less so for the compute. So this, as I mentioned, these are some exemplars and model concepts that we're working with, and we would love to get feedback on these from the community. Next slide. All right, so our plan is to consistently engage with entities that I've mentioned who have varied resource needs over time as HPDF offerings develop and grow. Spokes are our priority, and much of our initial efforts will be around that. We are starting to engage with various science communities and the IRI, and we will over time start to interface with different spoke type communities and try to figure out how they may be pulled into the 413 project. We also have plans to engage with ASCR Research Project, as I said, and that will be part of our conceptual design process. Next slide. All right, this is my slide just sort of showing a little bit of a longer term vision for HPDF, where we anticipate extending the hub and spokes with partnerships. We do expect a pilot deployment as part of the 413 project, and then we expect that the 413 project will have some initial spokes that will serve the urgent community needs and demonstrate the functionality that HPDF will provide. We are continuing to engage with various stakeholders to eventually establish spoke candidates, and more information will be forthcoming in the coming months. As Amber mentioned, the ASCAC subcommittee presentation and the charge, there is an anticipation of two large projects in the long term, Spokes 1 and 2, which we anticipate will have a large programmatic component and possibly joint project funding between ASCR and relevant program offices. And early spokes will be in tight partnership with the HPDF project, contributing to technical innovation and eventually operational HPDF. So we expect these spokes to be intellectual partners and advance the data lifecycle of efforts across the SC complex. Next slide. All right, so we do have a number of things we have ongoing. This is just a quick summary of that. That as Graham and Shane mentioned, we're working on the conceptual technical design and scope and alternative analysis that will include the design of hub and initial spokes. We have been doing a number of outreach activities over the last few months. We are a relatively new project. We were only announced in October. And these activities have involved attending and presenting at the Lightsource meeting in Jan. We did present to the IRI Management Council in April. Part of our team will be at the FES PI meeting next week, where we will be engaging with that community. There's an ASCR organized HPDF IRI workshop that's coming up in July in person. Much of the logistics and details for this workshop are still being worked out, and there will be more details sent out. Following that IRI workshop, what we anticipate doing is having a number of small group interviews with groups identified, and have a much more deep dive and discussion about requirements and understanding of their technical requirements and partnership models and things like that. We will also have presentations and other things at supercomputing. If you are there, we would love to talk to you. So please reach out. And if you think there's other engagement opportunities to engage with a DOE program or a community meeting that we can participate in for outreach, please do reach out. We'd be more than happy to talk about and figure out what might be appropriate. Next slide. All right, so I want to finish out here by thanking everyone for coming to our first webinar. We are very excited for what we are building for the community and very excited for all the work ahead of us. To stay informed, you can go to our website that's up here, connect with us on LinkedIn and YouTube. The slides and the recording from this presentation will be all posted online. And I also want to remind you that if you want to share your thoughts or you have some questions, you can use the QR code on this slide to post some questions or comments, and we will generate an FAQ within a few weeks to answer all the questions that come up. On that note, I want to thank everybody for coming, and I'll leave this slide up. Thank you.